Hello students, today's video is for Unit 1, Day 7, Systems of Measurement. This is due on Monday 8-25 for odd periods, Tuesday 8-26 for even periods. Today's lesson over systems of measurement, we need to talk about two different systems. Specifically today we'll focus on the SI system, since this is what we will need for physics class most frequently. The first type of system is probably the one that you're most familiar with. It's actually called the U.S. customary unit system, U.S. meaning United States. And really this is the units that are used mostly in the United States. Most of the rest of the world chooses to use this system because this system's a little bit easier. It's also the system that we will be using in science class. But for U.S. customary units, things that you should be familiar with are measurements for length, inches, feet, yards, and miles, for mass, pounds, and tons, and for time, minutes, hours, days, and years. SI units have very specific, just a single unit for each of their different base measurements. So the first one is length, which uses meters, which we abbreviate as M, mass, which uses kilograms, which we abbreviate as kg, and seconds, which we abbreviate as S for time. Just a really quick mention, the SI here stands for International System. I know then you're probably asking why isn't it IS? The reason is because originally it was in French, which they apparently had the words backwards. So we say SI units, you should think of the International System of Units. So the reason that the rest of the world and scientists really love the SI units is because you are able to use what are called metric prefixes. Prefix just means it comes before a word. So you'll learn this in English class, but you're also learning it in science class. So these prefixes can be attached to the base units. I use this term loosely because you'll notice that this does not necessarily mean that they are our SI units. So for example, we've got meters, again, which is M, grams, which is G. Note that I don't say kilograms. Kilograms actually has this prefix, which is a K. And kilograms is the actual SI unit, but G would be the base unit I mentioned over here. Seconds, S, and then liters. Remember that liters is not actually an SI unit, but it still is able to use these metric prefixes. You'll notice that we have them right here. Anytime we add the letter in front of the unit abbreviation, so for example grams, all we use are these letters. So for example, if I wanted to say hectograms, I would just put an H in front of my G. Otherwise, if we're going to spell it out, we would put the actual word in front of the actual unit. So I would write, for example, hectograms. The thing that we need to know is that these are right here, these numbers, is what we end up multiplying the number of, for example, hectograms we have in order to figure out how many of the base units we have. So for example, a hectogram is 100 times larger than just 1 gram. So for every 1 hectogram, there's going to be 100 grams. It's 100 times larger. Whereas for a centigram, for example, that's 100th. So for every 1 centigram that we have, it would be 100th or 100 times smaller than 1 gram. And we'll see what that means in the next slide. So for example, let's say I was trying to convert 1.62 kiloliters to liters. So we can see right here that we've got our kiloliters, which is 1,000 times bigger than a liter. So to get this, I would say 1.62 kiloliters times 1,000. And if I were to do this in my by hand or in my calculator, I would find out that this would end up being 1,620 liters. So for every 1.62 kiloliters we actually have 1,000 times that many liters. For centigrams right here, we can see centa means it's 100th, so 0.01 of a gram. So if I had 13.4 centigrams and I multiplied it by 0.01, I would end up with 0.134 grams if I were to multiply that out. Just so that we have a couple examples of our different units that we can use with our metric prefixes. Let's say I've got 5.71 hectometers. We can see here hecta means that it's 100 times larger than a meter. So I'm going to multiply by 100, and I should end up with 571 meters. And last but not least, let's say we've got 26.3 microseconds. A micro looks kind of like a backwards U with a long left side. A microsecond, we can see right here, is a millionth, 0.000001 of a second. So I'm going to multiply by 0.0000001. And if we were to multiply this out, what we would end up with would be a really tiny number. It's going to be 0.00000263. So we would end up with a very, very tiny number of seconds right here. So make sure that you understand how to use this table because it will be important for Monday and Tuesday. That's it for today. Make sure that your notes are in the upper half of page 9, that you do 3 main points in your own words, that one of those main points you connect to your own life. Please remember that your saltwater lab is due on Monday for odd periods, Tuesday for even periods. Both the lab outlined and the calculation/graph/data help sheet can be found at larkinators.weebly.com. See you later.